This is Precalculus section 12.3 notes, day 1. Today we are going to be talking about tangent lines and derivatives. And I know right now you have no clue what a derivative is. I promise more information to follow. But hopefully you do remember what a tangent line is. Okay? So here's our problem. What is the equation of the tangent line to the function f of x equals x squared at the point 1, 1? So here's the point 1, 1, and y equals x squared. We know that's just a parabola. Well, we know that the information needed to write an equation of a tangent line, because a tangent line is just a straight line that is touching that parabola at that point 1, 1, right? So if I were to kind of sketch the tangent line, it would look something like that. Well, the information that we need to write an equation of any line would be a point. So in this case, we want the point to be on the tangent line. And we need a slope of the tangent line. So those are the things that we need to figure out. So take a look below at diagram 1. We've selected a point on the graph. Right here, we're just going to call it point T, okay? And so if point T lies on the parabola f of x equals x squared, then this point T, we're just going to refer to the point as its x value being x and its y value being x squared, because whatever x is, if you plug it in and you square it, that's what the y value would be. And then we've still got our point P, which is at 1, 1. So if we were going to try to find the slope between these two lines right here, this creates a secant line. And the slope of the secant line, we know our equation for slope is y2 minus y1 divided by x2 minus x1. So for this particular picture, the slope of our secant line would be equal to the y2 value we're going to call t.2 and we're going to call p.1, okay? So then y2 minus y1 would become x squared minus 1, x squared minus 1. And then x2 minus x1 would just become x minus 1 in the denominator. Now look at diagram 2. We've taken that point T and we've moved it a little bit closer to P. So now we still have a secant line, but now it's just a little bit shorter. But if we want to find the slope of that secant line, it's going to be the exact same equation as before, because it's still going to be the x squared minus 1, that's our y2 minus y1, divided by x2 minus x1, which is just x minus 1. So this is the same slope that was found in diagram 1. Well, what does this mean? If we continue to move our point T closer and closer and closer to our point P, then ultimately what we're looking for is the limit of the slope of the secant lines. So really, our slope is going to be equal to the limit as x approaches 1 of x squared minus 1 over x minus 1. And then we go into our bag of tricks. We can't do direct substitution here to find our limit, because if we were to plug 1 in, that would give us 0 in the denominator. Well, one thing that we know we have in our bag of tricks is factoring. And since we have a difference of squares in the numerator, I am going to factor that numerator. So again, our slope is going to be equal to the limit as x approaches 1 of x plus 1 times x minus 1 over x minus 1. And then you can see that our x minus 1s would now cancel out. So we end up with m equals the limit as x approaches 1 of x plus 1. And when we plug 1 in, we get 1 plus 1. So that tells us that the limit as x approaches 1 of x plus 1 is 2, which means that the slope of our tangent line is 2. Whew! So we now have the needed information to write the equation of the tangent line. We did all that work to find out that the slope of our tangent line is 2, and we wanted to write the equation for the tangent line at that given point P, which was 1, 1. We know point slope form of a linear equation is y minus y1 equals our slope times, parentheses, x minus x1. And whenever we're working with this equation, we're always plugging in our point for y1 and x1, and we're always plugging in our slope for m. So now we can just go ahead and do some basic algebra 1 here. Y minus 1 equals 2 times x minus 1. We distribute that 2, and then we add 1. So the equation of our tangent line is y equals 2x minus 1. This brings us to the definition of a tangent line. The tangent line to a curve y equals f of x at the point P, which is a f of a, is the line through point P with the slope of m being the limit as x approaches a of f of x minus f of a over x minus a, because remember our point is a comma f of a. This of course is provided that the limit exists. This is the work that we just did on the previous problem. So now let's apply this new formula that we have to the next example. It says find the slope of the tangent line to the graph of f at the given point. Our function is f of x equals x plus x squared, and the point that we're supposed to use is 2, 6. So keep in mind 2 would be our a, and 6 would be our f of a. So the value of a is 2, and the value of f of a we already know is 6, but if we didn't know that, we could just substitute 2 into the function, and f of 2 would be equal to 2 plus 2 squared, which would be equal to 2 plus 4, which we know is 6. So now let's go ahead and let's plug this into our definition of a tangent line. So we're going to get the slope will be the limit as x approaches 2, because that's our a value, of f of x minus f of a. So f of x is our function, x plus x squared, minus f of a is 6 divided by x minus a. And just as before, we can't evaluate this limit by direct substitution because we're going to end up with 0 in the denominator. So I'm going to go ahead and try to simplify by first rewriting my numerator as a trinomial in descending order, x squared plus x minus 6 over x minus 2. And now I'm going to look at factoring that. That's an easy factor. Two numbers that multiply to make a negative 6 and add to make a positive 1 are going to be positive 3 and negative 2. So x plus 3 times x minus 2 over x minus 2. Now you can see those x minus 2's are going to cross out. So we are left with the limit as x approaches 2 of x plus 3. So now we can go ahead and evaluate that. So our slope is going to be equal to 2 plus 3, which tells us that our slope is equal to 5. In the last example, it says to find the equation of the tangent line to the curve at the given point. So in the last example, we just found the slope of the tangent line. This time they're asking us to actually find the equation of the tangent line. Okay, so this time our function is different. It's f of x equals x squared minus 2, and the point that we're given is 1, negative 1. So again, this is our a, and this is our f of a. So a is 1 and f of a is -1. Our first step is to find the slope. So we're going to use our definition of a tangent line again. So our slope is going to be equal to the limit as x approaches 1, because that's our a value, of our function x squared minus 2 minus f of a, which is -1. So we end up with minus -1 over x minus our a value, which is 1. And now we just need to clean up a few double negatives here. So the limit as x approaches 1 of x squared minus 2 minus -1 becomes +1 over x minus 1, which is the limit as x approaches 1 of x squared minus 1 over x minus 1. And now we've seen similar problems before. We know that we're going to have to factor that numerator. So m equals the limit as x approaches 1 of x plus 1 times x minus 1 over x minus 1. The x minus 1s can now reduce, so we get m equals the limit as x approaches 1 of x plus 1, which when we now plug our x value in, we find our slope to be equal to 2. Now that we know the slope, the next step is to write the equation of our tangent line. So remember, to write the equation of a line, you need to know the slope and you need to know the point, which is 1, -1. So we have the information that we need to write our equation in slope-intercept form. Y minus y1 equals m parentheses x minus x1. Once again, we're going to plug those three key numbers in here. We're going to plug in our ordered pair for x1 and y1, and we're going to plug our slope in for m. So when we go ahead and do that, we end up with y minus -1 equals 2 times x minus 1. Chop, chop. That minus a negative, that becomes plus. Y plus 1 equals 2x minus 2. And then we subtract 1, and we end up with y equals 2x minus 3. Okay. So now let's make sure we actually did this right. So if we were to graph f of x equals x squared minus 2, that was our function. That's just our regular y equals x squared parabola, but with a vertical shift down 2. So its vertex would be right there at -2. And then we'd have a point up 1, right 1, and up 1, left 1, and then over 2, up 4, and then over 2 to the left and up 4. So here's the parabola that we'd be looking at. Okay. And so now the equation of the tangent line that we just found, 2x minus 3, if we add that onto our graph, hopefully it gives us exactly what we want. So we have a y-intercept of -3, and we have a slope of up to right 1. Up to right 1, up to right 1. What we were supposed to find was the equation of the tangent line to the curve at the point 1, -1. Well, here's the point 1, -1. That is the exact point where our tangent line touches our curve. So I think we've done our work correctly.